Hello dear students, now I will discuss about homogeneous differential equation. Just in the previous class, in previous exercise 9.4 we have completed. 9.4 exercise completely depends on separable variables, that is differential equation with separable variables are separable form. That is, we know differential equations of first order contain only dy by dx, first order linear differential equation, and just we have to write the value of this. And if total function is separable, means x, function of x and y are separated, can be separated, then just we write like this: dy and dx and f1x and f2y. If then take function f2y with dy and f1x with dx, and we can do it by integrating on both sides, getting one constant, and if there are given condition, then we can find the value of constant and put the constant in the general solution. That was the method for variables of separable form. Here there are different type of differential equations. Just here we are discussing about first order differential equation and linear differential equation. Okay, first order. Here first method was variables are separable form. Second is homogeneous differential equation. What is homogeneous? How can we say that the given differential equation is homogeneous? If equations are not separable, just first we see that whether the given differential equation is separable form or not. If not separable form, then we try to check for further method, whether it is homogeneous differential equation or the standard linear differential equation, first order linear differential equation. Their methods are different. So here for homogeneous differential equation, if the given differential equation is homogeneous, for that we have to write dy upon dx. If given differential equations are given in any form, just first of all we have to write dy by dx equals to related function related to x and y. Suppose this value dy by dx equals to function of x and y. Now if this function, right hand side, this function is homogeneous, function of 0 degree, if fxy is a homogeneous function of x and y with 0 degree, then dy by dx equals to fxy is called homogeneous differential equation. Okay. First of all, we have to write dy by dx equals to all thing are here. That is denoted by fxy. If this fxy is a homogeneous function of xy with 0 degree, homogeneous function of 0 degree in x and y, then this equation is called homogeneous differential equation. Clear? Now, how can we identify whether fxy is homogeneous or not? For that, testing is very simple. Okay. Just suppose this is our function and we have to check whether it is homogeneous or not. Clear? If this function can be written as a function of y by x or function of x by y, means in this, in every places you can get y by x, combination of y by x or x by y. If this can be written this or this, first method. If this can be written as a this function of y by x or function of x by y, then we can say this is homogeneous function of 0 degree. And second, if we put in place of x, lambda x, in place of y, lambda y, and we get lambda per 0 fxy, lambda per 0 fxy, then fxy is homogeneous function of 0 degree of 0 degree. Clear? Either we get like this or we can express fxy. We can express fxy either in this form or in this form. Both method we can use. X replaced by lambda x, y replaced by lambda y, that is f lambda x lambda y equals to lambda to the power 0 fxy. Then this given function fxy is homogeneous function of 0 degree in x and y. And also, if we can express this as a function of new function of y by x or x by y, then also this is called homogeneous function of 0 degree. Okay, this is testing. So now take a questions and solve from exercise 9.5. Okay, so take, and first of all, if homogeneous function, then our method will be by taking questions. Just I will discuss about it. Okay, so for 9.5, in each of the exercise, this is the given differential equation homogeneous and solve each of them. If homogeneous, then solve each of them. Okay, so here technique is solving technique. I will discuss during the solution of this question. So take question first, x square plus xy dy. So solution 1. Given equation, given differential equation is x square plus xy dy. X square plus xy dy, x square plus y square dx. X square plus y square dx. This is given differential equation. Okay, the first question is this. Here we see that this is not separable form. because if we can see that they are mixing, not separated. The function of x, y cannot be separated. So now we will test for homogeneous differential equation. For that, we have to write the value of dy by dx. So here, just we can write dy upon dx is equals to this upon this. So x square plus y square upon x square plus x into y. This is not separable. So we will test for homogeneous function. So dy by dx equal to this. Suppose this is fxy, say. Okay. Same is, you know. So suppose this is equals to fxy. Clear? Now, first of all, we have to decide whether this is this, or you can write this is equation 1. Okay. So dy by dx equal to this equal to fxy, say. It will be homogeneous equation if our testing for fxy. Now we see that we can use both method. Lambda x, lambda y, that is in place of x, lambda x in place of y, lambda y equals to fxy equals to this. So in place of x, lambda x, so lambda x square plus lambda y square upon lambda x square plus lambda x lambda y. Just you have to solve it. Here we see that lambda square common, x square plus y square upon. There also lambda lambda square, so lambda square common, x square plus xy. So we see that lambda square, lambda to the power 0, and get x square plus y square upon x square plus xy. That is what? Lambda power 0 f of xy. That is, we get lambda x, lambda y equals to this. What shows this? Function fxy is homogeneous function, which implies that fxy is a homogeneous function of degree 0 in x and y, in x and y. Therefore, given equation 1 is a homogeneous equation. Therefore, given equation 1 is a homogeneous equation by testing this. Okay, you can test also just like this. Fxy equals to, in another method, if x square plus y square upon x square plus xy, y by x or x by y. So we can take common in numerator x square, then 1 plus y upon x square. We see also take here common x square. So we can see that x y by x. We can write like this. So here we see that x power 0 and remaining part are 1 plus y by x square upon 1 plus y by x. Or we can write, see that this is the 1, this is y by x combination, that is function of x power 0 function of y by x. Okay, here 0 degree, this is 1, so f y by x is sufficient. Okay, so f y by x. Also we can take common y, then y square, then 1 plus x square upon y square, upon here y square common, then what, x square upon y square plus x by y, this function of x by y. So by this method also you can show that this is homogeneous. So if fxy is homogeneous, then given differential equation is homogeneous equation if of 0 degree, homogeneous function of 0 degree. Okay, so here 0, so 0 degree. If here another thing you want to 1 degree, 2 to 2 degree, 0, then 0 degree. So this should be homogeneous function of 0 degree. Then we can apply this method, homogeneous equation method. Okay, now to solve this homogeneous equation, what will be our method? Okay, so here we see that this is homogeneous function, differential equation. So to solve this, so to solve 1, we put in case of homogeneous function, if we can get function as of y by x, then we put y equals to bx. B is new variable combination, value of y equals to b into x. This is new. Okay, b is also function of related to x. Okay, here if this function of this for testing, then we can, if this type of combination are we can get, then we can also put x equals to b y, that is x is equals to b into y. Here b is function of y related to y, so here just we put y equals to bx, y equals to bx as we required. Okay, now this substitution is used, we will use in equation 1. So we can put y equals to bx here and here. Also dy by dx, what will be the dy by dx in this case? So implies, put this on differentiation, on on both sides with respect to x we get. Okay, on differentiation on both sides, on differentiation on both sides with respect to x. So here dy by dx, dy upon dx. B is function of also x. So this is, suppose b as it is and differentiation of x 1. So b plus x as it is and differentiation of b, dv by dx, dv by dx. Clear? Just we get like this. Okay, dy by dx equal to b plus x dv by dx. Clear? Now this two substitution we will use in this equation. Just put the value of y and dy by dx in 1. Now substitute the values of y and dy by dx in equation 1. We get y and dy. Here dy by dx this v plus x dv upon dx. Here this, and x square plus y means vx square upon x square plus x into dx, xy x into dx. Just we get it. Now here we can see that new equation just we get now is variable or separable form. Always you can get in case of homogeneous equation. Clear? After this stage, after substituting, you can get a differential equation with variable separable form. Here, after this line, you can write b plus x dv upon dx equals to, here see x square b square, so x square common, 1 plus b square, x square common. Here also x square common, 1 plus b, x square common, 1 plus b, just like this. Okay, so we get like this. This is equals to x dv upon dx equals to 1 plus b square upon 1 plus b minus b, just like this. Clear? B. Okay, we will get like this. Here we see that this is differential equation in v, and v is dependent, x is independent, and here this complete function of v, this is x, that is separable form. So you can get always separable form equation after this step, means after substituting the values. Now we will solve this equation for v in terms of x, and finally y equals to vx. So we can write v equals to y by x. V equals to y by x we can write after solving. So this equation can be solved. So x dv by dx equals to, just solve it. First 1 plus v, 1 plus v square minus v minus v square. This type of, by taking LCM. So 1 plus v, v minus v plus v square minus v square. Okay. So this is equals to what? X dv by dx equals to, here right hand side, v square cancel, 1 minus v upon 1 plus v. This is separable form. We can write like this. What? 1 minus v, 1 plus v dv equals to 1 by x dx. Just we can write like this. Clear? This is function of v with v, function of x with x, which is separable form. Okay. Now for solving this, integrating on both sides. Okay. Integrating on both sides, just write here. After this line, integrating on both sides, just integration of 1 plus v upon 1 minus v dv equals to integration of 1 by x dx plus c. Suppose c. Okay, constant c. Clear? Now we can solve it. How can we solve it? Just here integration is main thing. For solving differential equation, 50%, 50 to 70% work is for integration. Just for integrating it. How can we integrate? Linear upon linear. Just divide it. Okay, same degree, same degree. So just you can adjust like this. Also, what 2 minus 1 plus b. 2 minus 1 means 1 upon 1 minus b dv. We can solve it. Right hand side log x, log of mod x plus c implies, here we can see that 2 upon 1 minus b, 1 minus b dv, first part. Second part, minus common 1 minus b, minus common 1 minus b upon 1 minus b dv equals to log of we can take here c, log c, log c. We can just write like this, log c. Okay, modulus is not required for all time. Log x means x is positive. Okay, now this 2 upon 1 minus b linear factor, that is 2 of log of 1 minus b linear factor, and coefficient of variable minus 1 divided by minus 1, that is minus 2b log 1 minus b. Here this cancel, dv means d equals to log of x c. Okay, so solution of the equation may be given in different format, but you have to simplify it up to the possible stage. Okay, just simplify it here. Now we can write log of 1 minus b square minus log of xc equals to b. Just transfer b to right hand side and this take to left hand side, minus log and minus 2 go to the power, so minus here. So here we can write, for simplification, the answer will be what? Minus, suppose common, then log of, minus common, then log of this plus log of xc. So we can write xc 1 minus b square equals to b. Clear? So we can write what? Log of minus common log a plus log b. So log a plus log b equals to log a into b. So log a, this into b, this log of this xy xc 1 minus b square equals to minus b. So we can write x c x 1 minus b square equals to e to the power minus b. Now finally we can use the value of b as xy, since y equals to bx, y equals to dx implies v equals to y by x. So here we can write c x 1 minus y by x square equals to e to the power minus y by x. Okay. So solution, its solution is 9.51 x minus y square equals to cx e to the power. Okay, we can also write like this. This is also right answer. It is also right answer. But more simplify is this c x, here taking LCM, then x minus y square upon x square taking LCM. Then what x square equals to e to the power minus y by x. This is right answer, but you can also simplify like this. Here x is cancelled, 1x is remaining to here and c is go to here. So x minus y square is equals to 1 by c x e to the power minus y by x, and also you can write just as x minus y square equals to k x e to the power minus y by x. Okay, where k is constant is equals to 1 by c. This is given answer in book, but this is also right answer. This is right, this is right, this is right. Just you have to simplify up to the possible stage. That solution, see, just simplify it. Okay. Clear? So what is the process for finding solution of homogeneous differential equation? When we get a differential equation of first order, just first see whether it is separable form or not. If it is not separable form, then try for homogeneous function equation. For homogeneous equation, just we have to write what? Dy upon dx equals to function of xy. Say right hand side as a fxy, and test for this fxy for homogeneous function of 0 degree. If this function is homogeneous function is of 0 degree, then we can say the differential equation is homogeneous equation. If differential equation is homogeneous equation and this type of combination is present here, then we can put this is equals to b, that is y equals to bx. If this type of combination is present, then we can write this equals to b, that is x equals to by, and substitute this, and then we can get a new equation which will be variable separable form. And but by integrating on both sides, you can get solution first, and then finally substitute in place of b equal to y by x or b equals to x by y, and you can get the solution. Okay, so this is the solution of question 1. Okay, now take another question. So one by one questions in this exercise 9.5 are given as what? Homogeneous, for homogeneous differential equation, whether it is homogeneous or not. So for testing, just write dy by dx. Take question. Question 2 is very simple, so you have to solve it here from yourself. Just take question 5. Question 2, 3, 4 is simple. As a similar first question, you can do 2, 3, 4. Just take question 5. Okay, for solving. X square dy by dx equals to question 5. Given differential equation is x square dy by dx. X square divided by dx equals to x square minus 2y square plus xy. X square minus 2xy plus y square. X square minus 2y square plus xy. Sorry. X square minus y square plus xy. Okay, this is given differential equation. X square minus 2y square plus xy. X square minus 2y square plus xy. This is given differential equation in equation 5. Equation 1 already solved. 2, 3, 4 are as the same process in equation 1 you can solve. Okay, so now equation 5, differential equation. First of all, we have to see whether it is variable separable form or not. So here we can see that the given differential equation is not of the form of variable separable form. Just we get like this. It is not separable form. X and y cannot be separated. So we will test for homogeneous equation. Say, okay, this is fxy. This is equation 1. Also, this is equation 1. Clear? Now, just for testing, this is whether this is homogeneous equation or not. We can check for by any of the method, by lambda or y by x or x by y. So now we see that f of lambda x, lambda y, you can use in place of x, lambda x, in place of y, lambda y. So lambda x square 2 lambda y square plus lambda x into lambda y upon lambda x square. Now, here we see that lambda square, lambda into lambda square. So lambda square common. In bracket x square here minus 2 y square plus xy upon lambda square x square. So you see that lambda 2 to power 0 and get x square minus 2y square plus xy upon x square. Okay, this is equals to what? Lambda power 0 f x y. So we get lambda x, lambda y equals to this. This means what? The fxy, that is this is homogeneous equation function. Which implies that fxy is a homogeneous function. Homogeneous function of 0 degree in x and y. This implies, therefore, equation 1, this is a homogeneous differential equation. So homogeneous differential equation, for solving it, just we can put y equal to vx. So to solve 1, we put dy, y equals to vx. Y equals to vx. Y equals to vx. Also implies differentiation. By differentiation with respect to x equals to v plus x dv by dx. Differentiating with respect to x on both sides. Clear? Now value of y and dy by dx put here and solve it. We can solve. Okay. Now substitute. Now substitute the value of y and dy by dx in equation 1. We get, clear, y and dy by dx, value of y and dy by dx, we substitute in equation this. So we get dy by dx means v plus x dv upon dx. Left side, right side. X square minus 2y square. Y equals to vx. So vx square plus x into vx upon x square. Just this. Now see, v plus x dv by dx equals to here x square, here x square, here x into x square common, cancel out. Okay, so x square common, so we can get 1 minus 2v square plus v upon x square. 1 minus 2v square plus v. Okay, implies x dv upon dx equals to here what? 1 minus 2v square plus v minus v. Just v transfer to right hand side. The x square will cancel. 1 minus 2v square plus v. 1 minus 2v square plus v minus v. Minus v. So v cancel. Okay, 1 minus 2v square. Clear? After this line, just we see that this is a variable separable form equation in v and x, so we can solve it. Okay, after this line we see that variable separable form, so we can write like this: 1 upon 1 minus 2v square dv equals to 1 by x plus dx. 1 by x dx. Just like this. dv 1 minus 2v square, this 2 are cancelled. 1 minus 2v square dv by this, dv 1 upon 2, 1 minus 2v square dv equals to 1 by x dx, 1 by x dx. So integrating on both sides. This is separable form. Integrating on both sides, we get integration of 1 upon 1 minus 2v square dv equals to integration of 1 by x dx plus c. Clear? Here for solving this integral, what formula will be used? Because integration is main thing for solving differential equation. So here log x, you know, this is c log x here. What will be the formula for this? 1 upon a square minus x square, you know, 1 upon a square minus x square. Since integration of 1 upon a square minus x square dx, we know this is equals to what? 1 upon 2a integration of 1 upon a square minus x square dx equals to 1 upon 2a log of a plus x upon a minus x. This type of formula we know. So here we can set, taking common 2. So 1 upon 2 integration of 1 upon 1 by root 2 square minus v square dt. We can set like this. Why? 2 common, then 1 by 2 is here, 1 by 2, 1 by root 2 square, 1 by 2 minus v square, this dv this. Okay, here log x, log of mod x plus c we can write. We can write also log c here, log of c, log of c. Clear? Now here using this formula, so we write 1 by 2 of a means 1 by root 2 square, a square minus x square, a means 1 by root 2. So 1 upon 2 into 1 upon root 2, because 2 into a log mod a plus x, a means 1 by root 2, 1 by root 2 plus x means v upon 1 by root 2 minus b, a plus x by b minus x is equals to log of c into mod x. We can write here 2 to cancel, 2 and 2 cancel, so 1 by 2, no, 2 cancel not, root 2, 1 by 2, 2, so this root 2 go to here, so root 2 upon 4, root 2 by 4, here 1 upon 2 of this 1 by 2, 1 by 2, 1 by 2a, 2a, root 2, that means 2 into 1 by 2 root 2, so root 2 by 4, okay. Log of here 1 plus root 2v upon 1 minus root 2v. Now root 2 cancel out. Okay. This is equals to log of c of mod x. Okay. Now just simplify it for solution. Okay. So here root 2 upon 4 log of v means y by x. V means y 1 plus root 2 y upon x one minus root 2 y by x, just like this, equals to log of c mod x root 2 by 4 log of here x plus root 2y upon x minus root 2y equals to log of c mod x. Clear? Now, okay, this is it can be written, just see the solution. Okay, good. This is the solution. Root 2 means we can write 2 root 2 into root 2, so 1 upon 2 root 2, this can be written, and log of this x plus root 2y upon x minus root 2y equals to log of mod x plus c. Just write, answer is right given in this form. So you can write it is also right, it is also right, which is required solution. Which is required solution. Okay, which is required solution. You can write yes. Good. So just we see that what is the process. So first of all, you have to write dy by dx. If it is not separable form, then just write like this, and suppose this is fxy, and prove it homogeneous function by putting x equal to in place of x, lambda x, in plus y, lambda y, and get this equals to lambda upon 0 fxy. Then this is homogeneous function of 0 degree. So this is homogeneous differential equation. If this is homogeneous differential equation, then we substitute y equals to dx and differentiate it. Dy by dx equals to b plus x dy by dx. So these two value just put in the given differential equation, and then you can get variable separable form equation and in b and x, and solve that equation, and finally put b equals to y by x, and you can get the solution. Just simplify it up to the possible steps, just simplify it, and that will be the answer. Okay, so here this is the solution of question 5. Just 2, 3, 4 you have to do. Okay, same type of questions, 2, 3, 4 and question 6 just you have to do. Okay, question 2, 3, 4 and 6. These 4 questions for your homework, and do it also with this 1 and 5. 1, 2, 3, 4, 5, 6. 6 questions will complete it. So you have to do these 3 questions by using homogeneous differential equation method. Okay, and send me PDF file for your address. Okay.